In this example problem, we're going to bring back the service calls database. And we are going to play the role of an online retailer who is preparing staffing for the upcoming periods, the summer months. And we are going to make an estimate on what level of staff we're going to need to handle our customer service calls based upon the observed information that we have for the last 3 weeks or 21 days. So provided to us is the day number, and on that day, how many actual calls our company received. To make our forecast, we are going to use the exponential smoothing model. And when you do that, you need two things. Firstly, you need to decide what your alpha is. And alpha, when you use exponential smoothing, is basically a measure of how much weight or emphasis you want to put on more recent observations than older observations. If you had an alpha of 0, you'd be weighing all of the days in your model equally, which is basically just finding the average. If you put an alpha of 1, you would be putting all the emphasis on the last period or the last couple of periods that you had, and they're giving no consideration to what was before, which is essentially like the 3-day moving average method. But somewhere in between determines how much extra emphasis you want to give on the most recent days of data. So for our alpha of 0.20, it's relatively low. It's taking all of the days into consideration, but it is giving a little more emphasis on the last few days of our information to help us make predictions, which kind of makes sense when you think about it. Yeah, you can have, months and months of information. If you're trying to figure out what's going to happen tomorrow, the last few periods should be a better predictor of what's going to happen tomorrow than something that happened, say, 5-6 months ago. Most companies, when they do this, will use an alpha between 0.1 and 0.3, so we're right in the middle of that area. It'd be very uncommon for a company to use 0.8 or 0.9 because then you're really just making your estimate on the last few days, and you might as well use a moving average method. So the first thing you need to do is determine what your alpha is, and for our online retailer, they determine the alpha they want to use for exponential smoothing to be 0.20. When you use this methodology, you are always making predictions based upon what happened prior in the information, which gives you a little bit of a conundrum with the very first point that you have in the information, because you don't have any points prior to use. You can't make a model that's going to predict what happened on day 0 because day 0 doesn't exist. So when this is done, the most common thing that's going to happen, and what we're going to do in this problem, is for our very first day of predictions, where we've got to say what our model would have said had it had this information, we're just going to set our y hat, our predicted value on day 1, equal to the actual observed value that happened on day 1. And it's just the easiest way to do it, and it still gives you good information. So we're going to start there. And then afterwards, we're going to have to go through and fill in the rest of our y hat column using the exponential smoothing method. So what we're going to do is set up a formula. First, we're going to say that it's equal to, and open a parenthesis, and then we're going to take the actual observed amount of our response variable, in this case the number of calls that happened the day prior. So we're going to take that 309 in cell B2, and we're going to multiply that by our alpha, and our alpha is 0.20. And then I'm going to close the first set of parentheses. Afterwards, I'm going to add to it, so plus, open not 1 but 2 parentheses, the complement of our alpha. So if our alpha in this case was 0.20, the complement of it would be 0.80, but you could always just write in 1 minus 0.20. Easiest way to go about it. And we are going to multiply that complement of our alpha by the prior day's observed prediction, which in this case would again be 309, but now we're going to take it from the y hat column in cell C2. And I'm going to close that last parenthesis, and I'm going to hit enter. And I'm going to see here that it gives me a prediction of 309 for day 2. So it kind of makes sense when you think about it. Like, we're making predictions on past information. In this case, this is the only past point that we have, so the only predictor would be, hey, it's going to be equal to what happened the day before. But as we use our fill handle to fill in the columns, we start getting different numbers. And that's because for each one of these predictions, it's taking the last couple of periods that you had and making a prediction based upon that information, always putting a little extra emphasis on the most recent period or periods in your information. And you can kind of see our y hat following a similar trend. Like when our observed information goes down, the following day, our y hat prediction is going to go down. And when our observed information goes up in this case, well then in the following day over here, our observed information is also going to increase. So it's creating a model, taking everything into consideration, but following the actual trend, in this case, of what happened in your calls. And we can just assume this always going forward. We stop on day 21, we're going to have to make a forecast eventually for day 22, but we could use this forever to continue to forecast. So now that we have our y hat listed in here, the next thing that it's asking us to do is we are going to have to go through and make a line graph which plots the number of calls that we actually had against the accompanying exponentially smooth forecast for those same days. So what I want to do is highlight all of the information in columns B and C, Control Shift down to grab everything, and I'm going to insert in the line graph section right here the fourth one over, our line with markers. And that's what our chart looks like, and that is incredibly ugly, so let's fix it up a little bit. First, I want to get rid of all of this space over here, so I'm going to click on my y-axis, if it will let me. Try that one more time. There we go. We're going to format this axis. We're going to get rid of that empty space by starting our lowest bound at a point that makes more sense, and I'm going to go with 250 for the sake of argument. It just looks like a good spot to get rid of all that dead space in our graph. That looks a whole lot better. Let's go through, close this out, and let's insert some axis titles so people know what we're going to be talking about right here. Our y-axis represents the number of calls that we had. So this is going to be customer service calls. Our x-axis follows the number of days that we had. And then we can name our chart title something more fitting, like the number, why keeps popping out, the number of calls that we had against our smooth forecast. And then I guess my last thing to say when I'm looking at this right now is I really hate that this is called y hat in our legend down at the bottom, so I'm going to click on that. I'm going to right click after everything's highlighted, select the data, go to that y hat that's down here that I don't want to be named y hat, and I'm going to edit it. And the first thing it says, what do you want the series name to be? Let's call that series name right here our exponentially smooth forecast. Okay, and then when I hit OK one more time, and now it's a pretty good looking graph. And it is showing in this case that our forecast, the orange line, is following the trend. The more and more past information tends to go down, we keep dropping down. Whenever there's a huge spike in our information, our exponentially smooth information will start climbing back up because of that spike, but it will always lag a little bit behind. And here we do have a pretty good center line through all the information, smoothing out our forecast. You can see the actual observations bounce around it a little bit, but that's what our model is predicting. It's doing a decent job of moving with the general trend that we had, a decline when there's actual declines, going up when there's actually reason for us to believe that it's going to go up, whatever those factors were going to be. We got our chart, and we can use that to visualize this information for anybody that needs it. I'm going to shrink that and move it off to the side so it's not in our way anymore. The next thing that we want to do is use the exponential smoothing model to make a prediction, in this case, for what's going to happen on day 22. Over here, for the forecast for day 22, I can do the same concept that we just did to fill in that y hat column. So it's going to be equal to, open a parenthesis, our actual observation for the prior period. So if this is day 22, we'd have the actual observation for day 21, which is 309, multiplied by our alpha, which was 0.20, plus, open a double parenthesis, find the complement of our alpha is 1 minus 0.20, and then multiply that by what our exponentially smooth forecasting model predicted for the prior day, which was 310.95 in cell C22. Close that parenthesis, and using this model, we don't have actual information for day 22 because it hasn't happened yet, but using this model that we have right now, we are definitely going to make a fairly accurate prediction that we are going to need enough people to handle 310.56 calls on day 22.